Hi guys, welcome back to my channel. I hope you guys are having a wonderful day. Okay, so before getting into the problem, I would request you all to please subscribe to my channel for more videos. I have started with I actually started with LPP using graphical method maximization, and like now I'm doing minimization sum. This is the second problem on minimization. I have actually uploaded one more sum on minimization before this. I will give the link in the description box. If you want, you guys can check it out. Okay, so let's get into the problem. Right, as you can see, this is the objective function. We have got two constraints, and the best part is that in my previous video there was a sign change, so we had to change it. And this one, it's quite easy. You don't need to change anything, simply convert the inequalities into equality. So let's do that. That is 2x1, 4x2 will be equal to 16. This is constraint number 1. And 4x1 plus 3x2 equal to 24. This is constraint number 2. So my next step is I'm going to create two rectangular boxes and find the individual value of x1 and x2 for each constraint. Okay, as you can see, I am drawing it. Yeah, it's done. Right, so x1, x2, x1, x2. So when x1 is 0, x2 is 4. When x2 is 0, x1 is 8. When x1 is 0, x2 is 8. When x2 is 0, x1 is 6. Now the next step which I'm going to do is I'm going to plot the graph. Okay, as you can see, I have plotted the graph. This one is x1 and this one is x2. Okay, now let's see the first coordinate. That is when x1 is 0, x2 is 4. When x1 is 0, x2 is 4, means this point. When x2 is 0, x1 is 8, means this point. So let me just join the 2 points. Okay, so as you can see, I have joined the points. Let's see for the second one. When x1 is 0, x2 is 8, means this one. And when x2 is 0, x1 is 6, means this point. So let me join the 2 points. Okay, as you can see, I have joined the second point as well. Now this next step is I need to find the IBFS. Okay, the thing is, since my question is minimization, and you remember my question was greater than equal to, so when both the constraint are greater than, suppose if I consider this constraint greater than means outside, and if I consider this greater than means outside, I cannot choose this one, because if I choose this one, this constraint, this will be lesser. It's not possible, isn't it? For both the constraint, it has to be greater than. So the only possible factor is this place, right? So this constraint and this constraint. So this area is my IBFS. Now how to find it? Let me just mark it. Right, this point, let me just mark it as A. This point, let me mark it as B. And this point, let me mark it as C. Okay, so for A, I know what are the coordinates, that is 8 comma 0. For C, I know the coordinates are it's 0 comma 8. But for B, I don't know the coordinate. How to find out? Simply equate the two constraints and find the value of x1 and x2. Whenever you get the value of x1 and x2, x1 will be x and x2 is y. So I will get the coordinates. So let's do that. Okay guys, I have written here, as you can see. So this is the first constraint, this is the second constraint. I'm simply going to equate it to get the value of x1 and x2. So how to write this? I'm going to do it like you were taught back in your school. So simply multiply the value of 4 with the first constraint and multiply the value of 2 with the second constraint. Okay, so let's do that. So this will be 8x1 plus 16x2 equal to 64, and this will be 8x1 plus 6x2 equal to 48. Okay, so this will be eliminated. This will be my 10x2 and this will be my 16. So x2 will be 1.6, and if you put the value of x2 in any one of the two equations, you will get the value of x1 as 4.8. So for point B, the coordinate comes as 4.8 and 1.6. Now the next step is I'm going to find the optimized value using the point A, B and C. Let me write it. Okay guys, as you can see, I have written the point A, that is 8 comma 0, B is 4.8 comma 1.6 and C is 0 comma 8. So these are the x1s and these are the x2s. Now what I'm going to do, I'm going to put this in the value of x1 and x2 in my objective function. So this is x1 is 8, x2 is 0. Let's see the objective function. Okay, as you can see, this is the objective function. So x1 is 8 and x2 is 0. So that is, you get it as 6 into 8 is 48 and plus 3 into 0 will be 0. So my z will be 48. As you can see, I have written here 48. So let's see for point B. That will be 6 into 4.8 plus 3 into 1.6. We will get it as 33.6. Okay. And for the third one, that is 6 into 0 plus 3 into 8, we will get it as 24. So now you need to find the optimized value. Since this is a minimization problem, so obviously after comparing all the three values, I need to find the minimum value, and out of 48, 33.6 and 24, you can easily find that 24 is the minimum value. So this is my optimized value. As you can see, I have written here my optimized value is 24, where the value of x1 is 0 and x2 is 8. This is my final answer. Thank you so much guys for watching my videos. Please subscribe to my channel for more videos. This is the second video on minimization. I will post few more sums on minimization so that you get a crystal clear view on this topic and you won't have any difficulty in your exam. So thank you so much for having so much patience, and I will meet you guys in the next video. Thank you, bye bye, and have a nice day.